Hello, this is Simple Math for you. Today we are going to revise for the end of year exam 25-26, and this is part 2. First, we are going to start with lesson 12.1, conjectures and counter examples. So in this lesson, we are going to identify patterns in numerical or visual sequences and formulate conjectures describing the pattern. So what is the meaning of conjecture? Conjecture is the description of what had been happened or what has happened here. Describe what has happened, the conclusion. This is how we deal with the conjecture, and accordingly we can find the next term. And if you understand how the sequence is going on, then it's easy for you to find the next term. So let's start with this question. Write a conjecture that describes the pattern in each sequence, then use your conjecture to find the next term in the sequence. Let's see this sequence. In this sequence, you will notice that the numbers are increasing by 3. So we can say that our conjecture is adding 3 to the previous term. Or you can say it in a different way, increase by 3. Or we can say each term in the pattern is 3 more than the previous term. Any description of what has happened is acceptable here. So accordingly, you know that this has been increased by 3, increased by 3, increased by 3. So that means the next term can be found by adding 3 to 11. It will be 11 plus 3, which is 14. So easily, conjecture is the conclusion. Let's see this one. We can see that here the next term is multiplying by 1 over 3, or you can say dividing by 3, or we can say that each term is 1/3 of the previous term. So we can write it in any way you can see it's making sense. So the conjecture is multiply by 1 over 3 or divide by 3, or you can say also it's 1/3. Yeah, each term is 1/3 the previous term. That's it. So the next term will be by multiplying by 1 over 3. So 1 over 27 times 1 over 3, which is 1 over 81. And this is a pattern, as you see, visualizing pattern. As you see here, this section is moving one section counterclockwise, عكس عقارب الساعة, from its location in the previous circle. So it was here, it becomes here, then next time it will be here, here. This is the first term, this is the second term. So I expect that the next term will be here. And this will be a circle, and the shaded part will be this part. So we will say that the shaded section is moving one section, 1/4 counter clockwise. Okay, that's it. Now let's see the next part. Evaluate whether a conjecture is true or false using the logical reasoning or examples. How can we do that? We can also understand what is the meaning of the counter example. Determine whether each conjecture is true or false. So if this is the first requirement, then find a counter example for any false conjecture. Let's see this one. Number 11. If n is a prime number is a prime, then n plus 1 is not prime. So first let's explain what is the prime number. Prime number is the number that has only two factors, two different factors. So 1 is not a prime number because it has 1 and 1 itself. Yani. So the number 1 is not. Starting with 2. 2 has two different factors, 2 and 1. It's divisible by 2 and by 1 only. So it's prime. Moving to 3. 3 has only two factors, 3 and 1, not other. 4 is not a prime number because it's divisible by 2, it's divisible by 4, it's divisible by 1. So it's not prime number. So we will exclude 4. Moving forward, 5 is a prime number, 6 is not, 7 is a prime number, 8 is not, 9 is odd but not a prime number because 9 is divisible by 3 as well. So it's odd but not prime. So we move to 11, etc. Conclusion. The only even number that is prime is 2. And not all odd numbers are prime. Example, 15 is odd, but not prime because it's divisible by 3, it's divisible by 5. So that means all even numbers are not prime except who? Except the 2, because it's the only one that has two factors, two different factors, 2 and 1. All odd numbers are prime? No, not all odd numbers are prime, but all prime numbers are odd except the 2. We have now understood what's the meaning of prime numbers. So let's assume that n is prime and check what is n plus 1. If you take n, for example, equals to 5, it's a prime number. What is n plus 1? It's 5 plus 1, which is 6, which is not a prime. This is a prime, this is not prime. So what he says was true. If n is 11, it's prime. If you add plus 1, it's 12, it's not prime. So far, everything was he said was true, except the special case when n is 2. When n is 2 and you add 1, this is prime and this is prime. So this proves that his statement is false. So the statement is false, and this example that I have written is called the counter example. So counter example is the example that shows, that proves, that demonstrate that the conjecture is false, that proves my opinion. So I'm saying it's false, so I'm providing an evidence. This evidence is called the counter example. Now let's move on. Here we have product of odd integer and even integer. He says that it's always odd. Product is the result of multiplication. So let's assume any odd integer like 1, 3, 5, 7. Let's assume it's 7. Even integer, integers that are divisible by 2. Integers, by the way, not fractions يعني. عدد صحيحة. Even integer like 6. 7 times 6 is 42. While 7 is odd and 6 is even, the result is even. The product is even, and he said the result is odd. This is enough to prove that his conjecture is false. So his conjecture is, statement is false, and this is the counter example. This is the counter example. Moving, if angle 2 and angle 3 are supplementary means their sum is equal to 180, then angle 2 and angle 3 form linear pair. Let's remember, what is linear pair? Linear pair, two angles sharing a side, as you see here. For example, this is 2 and 3. Their sum is always 180 because they are forming a line. So this is linear pair. Now let's go back to what he's saying. Is it always the case that angle 2 and angle 3, if they have a sum of 180, they should look like this? Of course, no. We can draw any separate angles. This is angle 2. And we can say that this angle is 70. And this is another angle, which is angle 3. This is angle 2, angle 3. We can say that this measure is 110. These angles are supplementary. If you look for carefully here, these angles are supplementary, but they are not forming linear pair. So this is enough to prove that his conjecture is false. So false, and this is the counter example. We have many. For example, if you have two parallel lines cut by a transversal, cut by transversal, this is a line, then we know that this angle and this angles are supplementary. They are called consecutive interior angles. They are not forming linear pair, but they are consecutive interior angles, and the lines were parallel, cut by transversal, then it's not linear pair. So this is another counter example. You can consider also this is another example. Okay, now it was enough now for us for lesson 12.1. Let's move to 12.2. 12.2 is talking about statements, conditionals, biconditionals, etc. So let's see here the first part. Use the statement below to write the compound statement for this and that. Let's remember what are these symbols. This stands for and this stands for or. Up or down and. Statements can be combined either with a or and. What will be the result? What are the possibilities? If you have two statements, the statement P and the statement Q, and you are combining them, the first statement can be true and the second true or false, false true, or false false. If both statements are true and you are combining them with or, then this is true. Or is a nice combination tool, we can say. It will be always true unless both statements are false. So for any statement, for any true statement, the or statement will lead to true. أي statement فيه true على طول true. So this is true, this is true, this is true, but this is false because none of the statements was true. But for the and, it's the opposite case. Means when I say the opposite case, means what? If you combine with and, any false statement will lead to false combination. So this has no false statement, so it's true. But all those, if you look at those, false, false, false. Any false statement will lead to false. So the only case that it will be true if both statements together are true. So let's now read what is required. First, we need to write the compound statements. So these are the statements given. I'm going to rewrite them and combine them with and. So I will write -3 minus 2 is equal to -5, and 2 plus 8 is more than 10. So I have rewritten them. Then I will check whether each statement is true or false. Checking statement by statement. Is this statement true? -3 minus 2 is equal to -5. Is it true? Of course, yes, so this is true. And 2 plus 8 is more than 10? No, this is false because it's equal to 10. True and false is false. So you are going to first write, don't forget, you need to write the statements properly, then check. Now, this was for and. Let's check for or. So we'll do the same thing now. This was what? This is P or what was the second? Q. But this one, the first one, was P and Q. So going back to this statement, now we were at our, the other one, 2 plus 8 more than 10. Now let's check. -3 minus 2 equals to -5. That was, we said that is true, or this one was false. True or false is true. So the statement has one for a true statement, the combination, the combined statement. So we will say that it is true. And it's called disjunction. And this is the word conjunction, disjunction, conjunction and disjunction. I mean conjunction and disjunction. So conjunction, no need. Conjunction is and, that one is disjunction. Now let's see this one. Now another two different statements. Let's combine them. So we will copy the statements first with and. This one is, he said -1 -2. Sorry, I copied wrong. -1 -2 is minus. This is of course true. And 2 plus 3 is more than 5. This is false, صح? So true and false is false. There is one false statement. Same here, R or P. So we will copy vertical angles are congruent, or 1 plus 3 more than 4. Vertical angles are congruent, always true. What are the vertical angles? Remember, these are the vertical angles. When the lines cross each other, they are forming opposite angles. These are congruent, and this angle is also congruent to this. Or 1 plus 3 is more than 4. It is also false. So true or false is true. Okay, now moving to something additional part, which is this symbol. This symbol is the negation. Negation means it's the inverse of what you were saying. If the statement was true, then the negation is false. If it was false, then the negation is true. So let's first write it. He is combining P and negation of Q. So let's copy P. What was P? The sum of the measures of two supplementary angles, copy, is 180. Then or هذه or ولا and negation of Q. What was Q? This is the original statement of Q. He was telling you that 1 plus 3 more than 4. إيش عكسها? What's the negation? شو العكس? It will be less than or equal to 4. And now we are going to check one by one. The sum of the measures of two supplementary angles is 180. This is true. 1 plus 3 is less than or equal to 4. Now, after negation, it's true. It was wrong. Now, negation يعني العكس, not false. يعني it كانت false, صارت not false. So, true and true is true. So, the result is true. Now, moving to second part, which is talking about conditional statement. And we will write it in if-then form. Condition يعني شرطي. في if وفي then. So let's check what is the meaning of conditional statement through questions. Question 18, identify the hypothesis and the conclusion for the given conditional statement. Then write the statement in if-then form. Now, this is a sentence. The intersection of two planes is a line. It's just a statement. If you want to convert the statement into a conditional statement, it will be looking like if this happened, then other will happen. So let's see. How can we rewrite it, paraphrase it? So we will say if lines or if the planes intersect, then the result or the intersection is a line. This is the conditional statement. يعني حولناها لجملة شرطية. حولناها لإيش؟ لإف then statement. So how can we identify the hypothesis and the conclusion? The hypothesis is the statement that follows if before then. This is the hypothesis. So the hypothesis part اللي هي الفرضية, the hypothesis, you just copy the statement. يعني the planes, I repeated that twice. Intersect. And actually, it's two planes. So here we have two planes intersect. Yeah, two planes intersect. So the planes intersect is the hypothesis. What's the conclusion? The intersection is a line. So this is called the conclusion. Conclusion هو النتيجة يعني أو الاستنتاج. So the intersection is a line. And usually if then statement يعني إذا سمينا الستيتمنت الأول P if then Q, it's going one direction. If P happens, then Q will happen. Now, another statement. The area of a triangle is half BH. So we can write it in this way. If the figure or the shape is a triangle, then its area is or will be half BH. So what is the hypothesis part? Hypothesis is this part. The figure is a triangle. So the figure is a triangle. Now, what is the hypothesis? What comes after then? So the conclusion that comes after then, يعني its area is half BH. Clear? Here the same thing. The sum of the measures of two complementary angles is 90. So we can rewrite it in this way. If two angles are complementary, then their measures مثلا أو the sum of measures is 90 degrees. طيب. So this part is the hypothesis. No, Nadi, خلاص to copy. This is the hypothesis. And the other part, I will choose another color. You can copy it. Is the conclusion. Enough for this part. Now we are moving to related conditional statement. They are conditional statement, but in a different structure. They are called converse, inverse, contrapositive. Of conditional, all are conditional statements. Now we are going to analyze their truth values. And we'll see whether the statement is true or false. So what is the converse? What is the inverse? What is the contrapositive? We just agreed that we have P to Q. If P then Q يعني, this is called the conditional statement. Now the converse is this way. What does that mean? The hypothesis turns to conclusion, the conclusion turns to hypothesis. So we will reverse the direction. Now we have two more. What are these two more? We have inverse, as you see here, and contrapositive. The inverse is as follows. What did I do? I negated the original conditional statement. If not P, then not Q. While the contrapositive, I will reverse the direction of the inverse. Yani it is negated, but negated of Q going to negating P. Usually, there are some statements are called logically equivalent. What is the meaning of logically equivalent? Means they have the same truth value. What are these? To remember them, the ones with verse are logically equivalent. Means if this is true, this is true. If this is false, the other one will false. Exactly the same. هذول بيسموهم equivalently logical or logically equivalent. And same for others, the leftovers. So contrapositive and conditional statement are logically equivalent. So no need to analyze each time. At the beginning we can analyze, but then you have to realize that this will turn to the same result. Converse, inverse have the same truth value. Let's see number 21. Noor is waiting to board an airplane or an plane. Over the speakers, she hears a flight saying, I will copy the statement. If you are seated in rows 10 to 20, then we turn it to conditional statement. You may board now. No problem. You may board. This is the original. هذا شو conditional. This is the conditional statement. Normal one. He said here in the question, write converse, inverse, and contrapositive for each true conditional statement. So this is considered to be true. So هذا true. أصلا true. It's given to be true. Now we will find the related conditional statement as we have discussed now. First, what do we need? هي طالب مين بعد؟ Converse. Converse we said it's Q to P. يعني هذا أول واحد, the first one is P going to Q, while this one is Q going to P. So you will reverse the directions. If you are boarding, if you are at board, or if you are on board, you can say that. Then you are seated in rows 10 to 20. Let's check the truth value. Does it make sense according to the concept? Yes, of course, because if they call in the speakers that the passengers seated in rows 10 to 20 may board, it's okay. This is the true statement. Now you go to that plane and you found that somebody is on board. So you realize that they were seated or they will have numbers from 10 to 20. So the opposite in this case is okay. So this is true statement. Okay, let's move to the inverse. Inverse, as we have agreed, it's negation going to negation to the original statement. So it will be if you are not seated in rows 10 to 20, then you may not board. It makes sense also. So this is true. And without thinking about it, we said that those are logically equivalent. Same truth values. يعني هذول اللي فيهم verse are the same. Lastly, finally, let's change the color here. Let's use now we want contrapositive. And contrapositive is this way. So if you are not on board, then you were not seated in rows 10 to 20. And this is also true, as it is compatible with the first one. If you are not allowed to board now, then you are not seated. It's the same. You can paraphrase it the way you like. Now, let's take another example. If two angles are complementary, this is originally, they said that it's true. So let's now do it faster. The converse means this direction. So if the angles, or if two angles are, you can say, if you have two acute angles, if two angles, you can say, then he's talking about two angles. If two angles are acute, then they are complementary. Complementary means they have a sum equal 90 degrees. Let's check. Is it always true or false? Let's take an example. If the first angle was 30 degrees and the second angle was another one, 70 degrees. This is acute, this is acute. Remember that acute angle is the angle that has measure less than 90 degrees. So let's add them. 30 plus 70 is 100. Is it 90 degrees? Are they complementary? No. So this is the counter example. So this statement is definitely false. And this is the counter example that we are providing. This is the counter. So when you ask to write false and write the counter example, just provide any two numbers. It's not necessarily 30 and 70. You can say 45 and 45. You can say 10 and 80. You can 10 and 20, 10 and 20, both acute. And if you add them, they are not add up to 90 degrees. Sometimes, yes, they can. For example, 30 and 60, both acute, but this is not the general case. So you just provide the example that shows that this statement is wrong. Now, moving to the inverse, we said that it's negation to the original one. So if two angles are not complementary, then they are not acute. Negation leads to negation. Is this true? Even without thinking, I will say false, because we said that those are logically equivalent. What is the evidence? What is the counter example? So let's see two angles that are not complementary. Not complementary. مثلا example, not complementary angles here 30 and 40. They are not complementary. They are not added up to 90 degrees. But this is acute and this is acute. So this is the counter example. Finally, we have the contrapositive. Contrapositive is reversing the negation. Yani if two angles are not acute, originally they are not acute, so they will not be complementary. Not and not. And this is true. First, because it's compatible with the first one, logically equivalent to the first one, or also you can justify it. If they are not acute aslan, they cannot be added to 90 degrees, definitely. If you take one of them not acute, how come you add 100 with something and turn out to 90 degrees? So it will be impossible. Now, finally, for this part of the lesson, if you live in Abu Dhabi Emirate, then you live in UAE, this is the conditional. So let's talk about converse. Converse, we said this direction. So if, this, he said that it's true. If you live in UAE, then you live in Abu Dhabi. Is this true? Of course, this is false. Because the counter example here can be you might live in Dubai or in Ajman or in Sharjah. Any of them can be a counter example. Now, this is the converse. Now, this is the inverse. If you don't live in Abu Dhabi, then you don't live in UAE. This is also false because I can be not living in Abu Dhabi, but I'm still in UAE. Same counter example can be used, by the way. You can live in Ras Al Khaimah. So you can use the same example. I am not living in Abu Dhabi. I'm living in Ajman, but I am in still UAE. And as you see, these are logically equivalent. Last is contrapositive. And it is if you don't live in UAE, then you don't live, and you can't live in Abu Dhabi. Yes, because if you are not in UAE, you can be in Abu Dhabi. So this is true. And this is because also it's logically equivalent to the original conditional statement. And this and that are logically equivalent, as we said. With that, we have discussed the most important parts in lessons 12.1 and 12.2 regarding the conjectures and the counter examples, and also the conditional and all the related conditional statements, and also the counter examples. Thank you so much for listening. See you in the next video in part 3. إلى اللقاء.